Hi, my name is Bahadur Akhmedov. Welcome to the course of Probability and Statistics. In this lecture, we're going to talk about the combinatorial analysis. We are going to introduce one of its most important rules or formulas called the general counting rule. And also, we're going to talk about two more important formulas. One is called the permutations, and another is called the combinations. And also we're going to talk about their differences. Like the formula for the permutations is calculated as p and k, and you need to calculate as n factorials divided as n minus k factorials. And formula for the combinations is c and k, where it's going to be calculated as n factorials divided as n minus k factorials times k factorials. So it's really important for us to know which formula we need to use in what cases. So basically we are going to talk about the differences between the permutations and the combinations, and also we're going to consider a couple of examples of their usage. So the reason why we need to learn the combinatorial analysis is that it helps us to calculate the probabilities. So for example, if you assume that there is one man and two women in a room, and if you choose one of a person randomly, what's the probability that this person is going to be a male? So what you need to do is you just need to make a sample space. So what kind of cases you can have? If you choose one person, you can choose the male, female, so female 1 or female 2, right? So if you would like to calculate the probability of choosing a male, what you need to do is you just need to divide 1, because there is only one male, to the 3 different cases. So it's possible to choose 3 different cases. What you need to do is you just need to count the number of possible cases of choosing a male, or in this case it's going to be 1, right? And the number of the cases of choosing any person from this room is going to be 3. So this problem is very simple, and you probably don't need a combinatorial analysis to calculate this kind of probability. But you can just make this problem a little bit more difficult. For example, if I say, hey, what if you choose 2 persons from this room, and one of them should be male and another one should be female. So what's the probability of choosing this case? So one male and another female. So well, if the order doesn't matter, so again, it's so much differences, so much complicated. So you can make this problem really difficult. So hey, it doesn't matter in which order they are coming. You can say, hey, the order is important, so depending on that, we are going to calculate this differently. So let's assume that now the order does not matter. So you choose 2 persons, one of them should be female, one of them should be male. So what's the probability of doing this? So first of all, we need to count how many different possibilities there exist. Right? So your sample space is going to contain like 3 different cases, like male, female 1, male, female 2, female 1, female 2. 3 different cases. So it's going to be simply 3 here on the denominator. And which of the cases are is this one? So 1 male and 1 female. So there are 2 cases, this one and this one, which fits to this case, 1 male and 1 female. So basically you just need to put here 2. So you see, so you can make these problems a little bit more complicated than you need the combinatorial analysis. So now always we have the chance to just write down all the items in a sample space. Sometimes we need to just calculate the 3 using some formulas or using some techniques. And the combinatorial analysis helps us to calculate those numbers like a 2 and 3 using the formulas. So the most important formula for the combinatorial analysis is called the fundamental counting rule. It basically tells us that, hey, if one event can occur in m ways and if the second one can occur in n different ways, then together in a sequence they can occur in m times n ways. For example, if I say, hey, your student ID, let's say your student ID has only 3 digits. like a 1, 2, 3 digits. I really like the boxes. I would also suggest you to draw the boxes in order to calculate the number of the cases. So if I say, hey, every box can contain the numbers from 0 until 9. So how many numbers, how many digits there? There are 10 digits, right? 10 digits. If every box can contain any number, any digit from 0 to the 9, how many different IDs we can generate? So this is one of the important examples and one of the important formulas in the combinatorial analysis. So in order to calculate the number of the different cases which you can generate, you need to just simply count, hey, how many digits you can put on the first one. So how many digits we can put? 10. So we can put the 10 digits on the second box and 10 digits on the third box. So this fundamental counting rule basically tells us that we just need to multiply them in order to find the number of the cases in total. So it's going to be 1,000 cases. So let me explain you this in a more easier example one more time. So let's say you have 3 letters, let's say A, B, C. Okay, so you can just use the 3 letters in order to generate the words, and your words should contain only 2 letters. So I would like to ask you, hey, how many words you can generate just using only the 3 letters? How many words you can generate just using the 3 letters? So how many letters we can use on the first place? 3. And how many we can use on the second? 3. So in total, it's going to be 9 different letters can be generated just using the 3 letters. So we can even list them. So it's going to be A, B, A, C, or B, A, B, 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 C, or it might be C, A, C, B, C, C. So 9 different words can be generated just using the 3 letters. Okay, so let's do a couple of more examples. So here is about an example about the football tournament. So if the football tournament contains 14 teams and every team contains 11 players, and now what we need to do is we need to just choose any team and from any and any player from any team. So how many different possibilities we have. So what we need to do is we just need to so 14 teams. Every team contains 11 players, so we need to choose one player, right? So obviously, it's going to be just number of the players. You just need to multiply 14 to the 11. So let me give you another example, which is more tangible. So let's say the ID numbers. So your ID numbers have the 7 digits. 7 digits. So let me draw this. 1, 2, 3, 4, 5, 6, 7. I always like to draw the boxes. Now every box can contain the digits from 0 to the 9. So how many digits? 10 digits. So 10 digits here, 10 here, 10 here, 10, 10, 10, 10. So if I would like to know, hey, how many IDs can be generated, how many 7-digit IDs can be generated, I just need to multiply the number of the cases for every box. And it's going to be 10 in a power of 7. So this is how much ID numbers we can generate. So let's consider another example. So the access code to the house security system consists of 5 digits. So each digit can be from 0 to the 9. How many different codes it is possible to generate? So let's assume that your house code contains 5 digits. 1, 2, 3, 4, and 5. So you just need to press them, right? Or I'm sorry. So it contains 5 boxes. What you need to do is you just need to type the digits to every box. So I would like to know, hey, how many different combinations I need to generate in order to break your house system, for example, right? So in this case, you just need to count, hey, how many digits you can write to the first place. So you can write 10 digits to the first place, 10 digits to the second, 10 to the third, 10 to the fourth, 10 to the last. So you just need to multiply them in order to know how many different combinations I need to try in order to break your house system. It's going to be 10 in the power of 5, and actually it's not a big number for a computer, so it's going to be 100,000 different codes can be generated. So now let's consider another example. So it's like generalized principle of counting. It basically tells you that, hey, if you have more than two experiments in a row, then you just need to multiply all the cases. So this is what we did already, right? So the general counting principle was only for the 2 cases when you have only 2 boxes, and the generalized version is going to be like many different boxes. So let's consider this example. So a university committee consists of 4 undergraduate students, 5 graduate students, 7 professors, and 2 non-university persons. So a subcommittee of 4 consisting of 1 person from each category is going to be chosen. So how many different subcommittees are possible to do? So let's say there is so members. Let's say 4 undergraduates, like the student leaders from every year, like from freshman, from sophomore, junior, and senior. And then 5 graduate students, 7 professors, and 2 non-university persons are in our in our pool. So what we need to do is we need to always make a committee. For example, after a semester, we are going to discuss some issues connected with the university, and this committee should contain 1 person from each category. Like for the first, you need to call a person from undergraduate. For the second, you need to choose a person from the graduate. For the third place, you need to choose one of the professors, and for the last place, you need to choose a non-university person. So the question is, how many different committees it is possible to do? So again, we are going to solve this problem using this generalized principle of counting. What we need to do is we just need to know, hey, how many different undergraduate students we can use. So there are 4 different undergraduate students, right? So how many different graduate students we can use? 5. So how many different professors we can use? 7. And how many different non-university persons we can use? 2. So the number of the different possibilities we can choose is going to be just the multiplication of those numbers. So it's going to be 20 times 14, so it's going to be 280. So we can generate 280 different committees. And you see, so just drawing the boxes in order to solve this kind of problems is so easy. So here is a solution for the problem. So now let's do another problem. So could you please arrange the following events in chronological order? It means like which event happens first, then which one second, which one happens third, and the last. So if I would have no idea, no clue about these events, I would just try to guess them. And I would like to know, hey, how many different possibilities, so how many different cases I can guess, I can generate, right? So is it going to be A, B, C, D, or B, A, C, D, or D, C, B, A, and so on. So what I need to do is I need to draw 4 boxes, and then I need to write down the answers, like say which event happened first, which event happened second, third, and fourth. So how many different events I can choose in the first place? So actually I can choose any of these events, right? For either A, B, C, or D. So if you choose one of them, for example A, you cannot choose this event anymore in the second place, right? So if you choose the B, for example, in the first place, then you cannot choose the B. So it doesn't matter which event you have chosen for the first place, A or B or C or D, you can choose this again in the second place. So it means that the number of the cases for the second place is going to be 3. So hopefully you're understanding what I mean. So for the first place, you can choose any of this. For example, let's assume that you have chosen A for the first place. So how many different options you have? 3 now. So let's say you have chosen B for the second place. So how many different options you can choose for the third place? 2, right? If you choose C, for example, then you are going to have only 1 option at the end. So you could choose different letters, but you would have again the same number of the possibilities. So in the beginning you have 4. You can choose, for example, D, right? So if you choose the D on the first place, you again have 3 possibilities for the second. You can choose, for example, B. Then you have 2 possibilities for the third place. You can choose A, for example. Then you are going to have just 1 possibility at the end. So it doesn't matter what you are going to choose, the number of the cases are always going to be 4, 3, 2, and 1 in these places. So what you need to do is now you just need to multiply them in order to know how many different possibilities we have. So it's going to be 12 times 2, it's going to be 24. So we can generate 24 different answers by putting this events in the chronological order. So again, let's do one more example on this. So during the summer, you are planning to visit 3 Asian cities in Uzbekistan: Samarkand, Bukhara, and Khiva. So how many routines it is possible to do? So when I say the routines, it means that so you just need to tell me how exactly you would like to go to these cities. So going to Samarkand first, then Bukhara second, then Khiva third is different than going to the Bukhara, then Khiva, and Samarkand, right? So it is really important for us to know the exact routine, how you would like to visit the cities. So how many different routines it is possible to do? So in order to do this, again, we are going to make the boxes. So how many different boxes we need to do now? So we need to choose the routines of the 3 cities. So that is why we have to make 3 boxes. On the first place, you need to choose a city where you would like to go first. So how many different cities you can choose to go first? So you can go either to Samarkand, either to Bukhara, or either to Khiva first. So there are 3 different cases on the first place. So if you decided to go to Samarkand, for example, right? So how many different cities you can choose to go to the second? So there are 2 different cities you can go to the second, and at the end there is only going to be 1. So it doesn't matter how you are choosing the cities, the number of the cases are always going to be the same. So let me explain you what does it mean. So if you decide to go, so in the beginning you can choose any of the 3 cities, right? So that is why you have 3 different options. If you decide to go to Bukhara first, you are going to still have 2 different cases to choose to go to the second place, right? 2 cases, and at the end there is only 1 case. So now if you would like to just generate the number of the routines, the different number of the routines, it is going to be just the multiplication of these numbers. In this case it's going to be 6. So let me change this problem a little bit in order to give you some feelings. We will come back to this now. So now let's make this problem a little bit differently. So let's say there are 12 regions in Uzbekistan. What you need to do is you would like to visit only 5 of the regions. So you can just like region 1, region 2, region 3, and so on, region 12. So if you need to choose 5 of these regions, so any 5, for example, you can choose R1, R3, R2, R12, or 11, for example, right? So you need to choose any 5 regions. So now what you need to do is you need to tell me, hey, how many different routines it is possible to do. So it's of course important for us to choose so what we need to do is we need to first of all we need to pick up 5 regions, and after we have picked up the 5 regions, we need to also take into account how many different routines we can do, right? How many different routines. Let me explain you what I mean. So if you choose, for example, Samarkand, Bukhara, Khiva, Khwarezm, and Jazakh, for example, 5 regions you have chosen. Now you can do many different routines just even using this 5, right? So you can go to Samarkand first, then Bukhara, then Khiva, Khwarezm, Jazakh, right? or you can just do this differently. So it's important for us to choose the 5 regions, then we need to kind of like mix their places. So in order to solve this problem, what we are going to do is to draw the boxes. What we need to do is we need to make 5 boxes now, right? Because we need to visit only 5 different regions. 1, 2, 3, 4, 5. So now what we need to do is we just need to count the number of the cases for every box. So in the first place, I need to choose where I'm going to go first. So how many different options I can choose? So to how many regions I can go? I can go to any region, right? So I have 12 options. So if you decide to go to the first, for example, so let's say that you've decided to go to the first. So now we cannot go to the first again, right? So it means that you need to choose one of the 11 because you have now 11 options. Then 10, then 9, then 8. So the number of the routines which you can create is going to be just the multiplication of those numbers from 12 until the 8. So it's actually called the permutation. It's going to give you the formula of the permutations. So we are going to write this down. So the ordered arrangement of the p distinct objects is called the permutations. The number of the ways of ordering n distinct objects taken p at the time will be denoted like this. So let me explain you what does it mean. So it means that if you have n distinct objects, what we need to do is we need to choose p of them. Choose p of them. So the number of the ways of choosing p out of n is going to be called the permutations. So as it was in our example with the cities. So we used to have 12 regions. What we needed to do is we need to choose 5 of them. So it's going to be the permutation. So we've just calculated it's going to be multiplication of the 12 until 8, but we can solve this using these permutations. So we used to have 12 regions, and we need to choose only 5 of them. It's going to be 12 factorials divided to the 12 minus 5 factorials. It's going to be 12 factorials divided to the 7 factorials. And if you divide this, you're going to get this number, right? So I'm going to just give you a brief insight about how you can divide the factorials. So please let me remind you that the 12 factorial means that the multiplication of the numbers from 1 to the 12. So, and the 7 factorials means the multiplication of the numbers from 1 to, from 1 to the 7, right? So here you have 7, 8, and so on. So you can just cancel those numbers, and what you're going to have here is 9, 10, 11, 12. Exactly this one, right? So you are going to have this answer by just putting everything to the formula. So this is what we are going to call the permutation. Permutation is choosing p objects out of n distinct. So here it's really important that the objects are distinct. And it's also important that the order is important. CBA is different from ABC. What do I mean? It means that if you are going to create the routines, it's really important where you're going to go first. So going first to Samarkand, then Bukhara is going to be different than going Bukhara and Samarkand. So I'm going to explain you what do I mean in a moment. So names of 3 employees to be randomly drawn without a placement from a bowl containing names of 30 employees in a small company. The person whose name is going to be drawn first is going to get $100. The individuals whose names are going to be drawn second and third are going to receive $50 and $25 respectively. So how many sample points are associated with this experiment? So what do I mean? So it means that there are 30 names. So name 1, name 2, name 3, and so on, name 30. So what you need to do is you need to choose one of them. The first one you choose is going to get $100. So the second one is going to get this $50, and third one is going to get $25. So how many different list of the winners who can create, right? So in order to do this, we need to make the box. So how many boxes we need to do? So we need to do the 3 boxes because there are only 3 places, the first, second, and the third. So now we need to count, hey, how many options we can put on the first one. It's going to be 30, so we can choose any of the 30 names, right? On the second, there are 29 names, and on the third, we are going to have 28 names. So we just need to multiply them. It's going to be 30 times 29 times 28. But we could just solve this problem using the permutations as well. So if you remember, the permutation means choosing p objects, right? So p in our case is 3 out of n distinct objects. It's going to be 30. So we have 30 distinct objects, and we need to choose 3 of them, where the order is important, right? So choosing a person first or second is important because they are going to get different number of different amount of money, right? So order is important. It's going to be 30 factorials divided to the 30 minus 3 factorials. It's going to be 30 factorials divided to the 27 factorials, which is 28 times 29 times 30. So this is roughly what does it mean, the permutations. So we